Okay, so we're asked to find x and y here for this. So what we have here is basically just a right triangle with a 40-degree angle here, and this is 12 millimeters. So we're looking at an inverse tangent, trying to find this angle. Or that side, sorry, angle, I don't know, yikes. So this is an inverse tangent of x over 12. Anybody gonna stop me? I was gonna say it's not an inverse tangent. You guys are really asleep this morning. What are we gonna do here?
I don't know. I just took the side equation and multiplied it by the tangent again.
Okay, so it's tangent of 40 degrees equals x over 12. And when you go to solve this, if you make it a proportion, it's going to be a tangent of 40 times 12. I was wondering how far you guys were going to let me go on that.
Well, I thought you were going back or something.
So at 10.07 millimeters. Over here, we've got 30 degrees and 12 millimeters, looking for y. So this is going to be tangent of 30 degrees equals y over 12. Put this over 1, so it'll be 12 times tangent of 30. .93 millimeters. So what does all this mean? Well, it's back to our block again, where we're drilling from corner to corner. This dimension here is our 12 millimeters. This one is the 6.93 millimeters. And this one is 10.07 millimeters. From that, we can now do pretty much everything that we did before. Pretend that hits there. So I want you to find, oops, this is the angle here that I actually want to find. Angle T and angle R. If I give you that this view has an angle here of 19 degrees, and this view has an angle here of 23 degrees. And you might be looking at that thinking, we don't have enough information. What didn't I give you here? I didn't give you a thickness, did I? Guess what? We don't need it. Here's what I want you to do. Richard and Eugene, I want you guys to use 20 millimeters as your thickness. You guys, I want you to, Dale and Bruce, I want you to use 50 millimeters for your thickness. See what you come up with for angles R and T. So, what'd you get here? 6.93. What'd you guys get there? 17.22. All right, well, we'll work both ways. What'd you get here? 21.22. You guys? 8.49. Okay.
I'm sorry, 6.89.
8.9, not 9.3. So R up here is going to be an inverse tangent of opposite over adjacent. So it would be this one over this one. So 8.49 over 6.89. Gives us 50.94 degrees. That sound right? Is that what you got? You got stuck? Or... If we did the other one, R is going to be the inverse tangent of 21.22 over 17.22. Guess what that comes out to be? Same thing. $50.94 degrees. If that doesn't convince you. Of course, we're going to have to do a fake L here, right? Even though this isn't really L because we're guessing that depth.
What are you doing with
The
the blue?
blue? What blue?
What are you figuring out after you figured out the length of those?
Oh, down here? Well, I found R by putting this one over here and this one here. Technically, this one goes here, but it's the same as the other end. And then, of course, whatever you use here is that depth, that height. So,
How the surface is flat and you have two surfaces that are vertical.
what do you mean?
You're looking at side views that are vertical.
Yeah, this is this face right here.
I get that.
So this dimension here is just this dimension here.
Right, but how can you figure out a dimension that's flat? If you've got,
Whatever you used here is this dimension, right?
you know,
And whatever you found here is just this dimension. So you've got all three dimensions just like we did in any of the other problems. I'm not getting what you're trying to ask.
I'm just not seeing it. That's okay.
The key is it doesn't really matter what this dimension is. The ratio of the dimensions is what matters because we're doing trig functions. So it doesn't matter what any one of the dimensions. None of these dimensions are correct. But the angles are. Because whatever we calculated you calculate the length, and you can use that to find t by putting that length, inverse cosine of whatever you used here over what you got for that length. Well, you're all going to get different lengths because you chose different depths. But the ratio will still be the same. What's t come out to for an angle? 28.66 sounds correct. Degrees. All you're doing is taking this picture that we did last time, right? Here's T, here's R. And what I gave you last time was X, Y, and Z, right? I gave you those dimensions, you could find those angles. That picture made sense, right? Okay. So all we're doing now is we're looking at this end. And if you look at that end, and technically I should have it like this. This is the axis of the hole through there, right? You're looking through it as a two-dimension. I mean, you're not seeing the depth.
Right.
Just like an end view of a drawing and a front view of a drawing. You're not seeing the depth. And then this is the angle you're given. Well, this is Z and this is Y. Then you're looking at this side over here. Here's that hole, and you're given this angle. Well, here's still Z. This is now X. So all you're doing is you're using Z and those angles to find X and Y. The tricky part to understand is it doesn't really matter what Z is. Because all you're doing is, you remember we talked about similar triangles, you can enlarge it or reduce it, the angles all stay the same. Same thing's going on here. We can enlarge this or reduce it, the angles are all going to stay the same. So we know the angles, we can pick whatever number we want to for Z. And the ratio of the sides is going to stay the same and the angles will stay the same. But we have to have sides in order to find the angles. Yep, 2866 is the angle T. Does that make any sense?
I just don't get how you can. Angle T is like in the center of the block.
Yeah, it's going through the center of the block, yeah.
Okay. How can you get an angle that's in the center of the block if you have an angle that's from this view and from this view?
Okay. Well, let's do this. Here's your block, right?
Yep.
So you're used to looking at it like this. Here's the hole coming in, here's the hole coming out. What we're doing is we're looking at it from this side, right? If this were a clear block, you could see the axis of the hole. We're given this angle. I mean, this is a two-dimensional projection. This is not T. This is just that component of T.
Right.
Now, when you look at it this way, again, this is not T, it's just that component of T. What it's doing is it's telling you this dimension and this dimension so you can figure out the box, then you can come back to T. You can't get directly from those dimensions to those angles to T. You have to use those angles to find your dimensions. But that'll get you to T. Now, there are formulas. Your packet does give you formulas that you can just plug in those angles and magically T appears. But I'd rather have you just pick side. Because, I mean, if you're out in industry and you need to do this, you're not going to have that formula memorized. And you guys haven't really stressed the machinery handbook to where you guys are good at running through the machinery handbook and looking stuff up right now. Any questions? Do you think you guys can do these on your own? No.
You give a work key to go.
Well, they should be in your packet. Page 401 to 404. 1 through 15, the odds. Your packet does give a shortcut formula where you can just plug in the angles. Where, well, the way the packet listed is like this. Tangent of angle R is equal tangent of angle D over tangent of angle B. So technically it should be R is the inverse tangent of tangent D over tangent B, where D and B are the angles that are given above. This is angle D, this is angle B. Then it tells you that tangent of angle T is the square root of tangent squared of D plus tangent squared of B. So technically T is the inverse tangent of the square root of tangent of angle D squared tangent of angle B squared. Is what that's saying. But again, I don't like memorizing formulas. They're there if you want to use them, but I would prefer that you just pick a depth and then use that depth to find dimensions and go from there. So page 401 to 404, 1 through 15, the odds. I'll give you guys some time because I'm thinking these might take a while.